Hello my dear students, welcome back to NEET World. So today's discussion is understanding the writing of electronic configuration. So how can we write electronic configuration for the elements? So in the last class we were discussing about molecular weights, atomic weights and molar mass and number of moles and their interconnections right now. So this is the thing we discussed in the last class. Anyways, we also solved some questions. I have given some questions as homework. Again I will be continuing that discussion also, but first of all let us have a basic understanding of electronic configuration. Okay, so now I will be discussing about electronic configuration from very basic level. So even if you do not know anything about electronic configuration, from this discussion you are going to write the electronic configuration for first 20 elements first. Okay, later we will do for other elements also. Okay, so again understanding electronic configuration for first 30 elements is most important first. Okay, then after that you can write for all 118 elements and their electronic configuration. Okay, right, let us start our discussion here. So yeah, so electronic configuration, today's discussion is electronic configuration. So I will start it from very basic. Okay, say if you consider an atom, so atom center part is called a nucleus. This is, let us say this red color part is nucleus, consider like that. And now the circular parts around this red color dot will be considered as orbits. What I am saying, shells or orbits. So these black color lines are what? The circles that you are seeing. So they are not actually circles, they are, you can like assume like a three-dimensional space around the nucleus. So let us say these are shells. What I am saying, these are shells. Okay, now in these shells we will be numbering like this. So n equals to 1. See, this is a nucleus now. So what is this red color part I am saying? Nucleus. Okay, so the first orbit which is around the nucleus is called n equals to 1, shell number L. Okay, 1. So I can represent it as K. Okay, and this is 2, K, L, this is M. Like this, as we write the circular parts, it becomes K, L, M, N, like this you can write, keep on writing them. So what is this? These are shell numbers. Okay, shell numbers. This is n equals to 1, n equals to 3, 4, like this you can write, n equals to 1, 2, 3, 4, you can write like this. Okay, so it means what happening as we go away from the nucleus, from the center, the n value getting increased. So what do we mean by n? N is nothing but shells. Okay, so these shells contains subshells. What they contains? Subshells. Okay, so within the shells we have subshells. Okay, so if shell number is equals to 1, what I am saying, if shell number equals to 1, then subshell number will be 0. Okay, so subshells are indicated with letter L, small l. So I am giving you this very basic, in a very basic manner. Try to understand, try to follow and understand. See, atom has a nucleus at the center. Around we have circular parts considered as shells. So in these shells we also have subshells. So shells indicated with symbol n, n equals to 1, first shell, n equals to 2, second shell, 3, third shell, 4th, fifth shell, fourth shell, like that we keep on having the shells, like that it goes on. Okay, now in every subshell there will, in every shell there will be subshell I am saying. So that subshells are indicated with the symbol L. Okay, so if n equals to 1, L can be 0, and if n equals to 2, L can be 0 and 1, like that you need to write. If L equals to 3, L can be 0, 1, 2. Okay, so always L value will be lesser than n value. Always subshell number will be lesser than shell number, because subshells are lies in the shell, na, that's way. You can understand like that. Okay, now let us take hydrogen atom. What is the atomic number of hydrogen atom? 1. Okay, so it is 1 na, so it contains shell equals to 1. Okay, first shell. Okay, n equals to 1. So hydrogen atomic number 1 means electron also 1 na. So in this n, so if n equals to 1, I can represent it as K also. So in K shell we have one electron. Okay, and in which subshell we have seen one shell, like n equals to 1 means subshell will be L equals to 0. So if L value is 0, that subshell should be indicated with the symbol S. If L value equals to 1, that should be indicated with symbol P. If L value equals to 2, that should be indicated with symbol D. Okay, if L value is equals to 3, symbol should be F. Like this we have. Okay, so now what is the n? We have 1 na. So because only one electron will be there, that lies in the first shell only. That first shell can be represented with K, or that can be indicated with 1. Okay, so in first shell, how many subshells are there? One subshell, that is L equals to 0. So that's why we are writing it as 1s with 1 electron, no? So 1 is 1. Okay, and the next helium. So 2 electrons should be there because atomic number is 2. So just follow me for the next 10 elements examples, then you can easily write the electronic configuration. Just follow me what I am explaining. So helium atomic number is how much? 2, right now. So 2 means the first subshell. What is the first subshell? Here we have n equals to 1. Okay, a first shell n equals to 1. Okay, so in this shell we have 1s orbital, because if n equals to 1, L value is how much? 0. So 1 0 means s. So 1 s you can write. Okay, so here you can fill 2 electrons. Okay, like this. Sir, we have some confusion regarding the filling of electrons. Can you explain me clearly? Yeah. So look at this. In any shell number, ఏదైనా ఒక షెల్ తీసుకున్నారు అనుకోండి, అందులో మనం మ్యాక్సిమం ఎన్ని ఎలక్ట్రాన్ ఫిల్ చేయొచ్చు అని అంటే, యూ కెన్ టేక్ ఇన్ ఎనీ షెల్ నెంబర్ ఆఫ్ ఆర్ maximum number of electrons can be 2n square. How many electrons you can fill? Maximum number is 2n square. For example, in the first shell, how many electrons we can fill? అంటే ఫస్ట్ షెల్లో మనం ఎన్ని ఎలక్ట్రాన్స్ ఫిల్ చేయొచ్చు అనే డౌట్ మీకు వచ్చింది అనుకోండి. షెల్ నెంబర్ ఫస్ట్ షెల్ అంటున్నాం కదా, షెల్ నెంబర్ 1 అంటే 2 into 1 square అంటే 2 into 1 square means 2. సో అంటే ఫస్ట్ షెల్లో in first shell how many electrons we can fill? Only maximum of 2 electrons. Similarly, in the second shell n equals to 2 now, so 2n square, n value is 2 square. So 2 to the 4 to the 8. So 8 electrons you can fill in the second energy level, that is second shell. Like that, if you go for third shell, so n equals to 3 now, 2n square. So here n value is 3. So 3 square is 9, 9 to the 18. So in the third shell, how many electrons you can fill? Maximum 18 electrons. Like that, if you go for the fourth shell, 4 square means 16, 16 to the 32. So here you can fill 32 electrons maximum. Okay, like that we need to know the count of electrons that we can fill in each energy level. In second shell, how many we can fill? 8 electrons maximum. In first shell, we can only fill 2 electrons maximum. So where these 2 electrons are now present? In 1s orbital, like 1s2. Next, lithium, hydrogen, helium, lithium, atomic number 3. Okay, so how many electrons we have in lithium? 3 electrons, because atomic number 3 now 3. So now how can you write? So first n equals to 1, so 1s. Okay, 1s, how many we can fill? Maximum of 2 electrons only. So 1 is 2 over. Then next, sir, first shell is filled now, so the next electron should go for the second shell. So n equals to 2. So 2, okay, with 2, what are the L values possible? 0 and 1. So 0 means S, 1 means P. So 2s. Okay, so 2s. How many electrons we can fill? Out of these 3, 2 are over here. One more, no, you can give it here. Okay, next, hydrogen, helium, lithium, beryllium. So atomic number is 4. So now 4 means how many electrons? 4 electrons. So how can you fill these 4 electrons? It can be like 1s2, 2s also 2. That's it, over. Okay, right. Next, here we have beryllium, boron. Atomic number is 5. Okay, next, carbon 6. So when it comes to these, 5 electrons are there now. So first 1s2 over, 2s2 over. How many electrons are over? Out of 5 electrons, 2 plus 2, 4 electrons are over. And the next electron, where it goes? See, L equals to 0 means S over, L equals to 1 means P. So P is there now, so you can take 2P. Okay, in each p orbital we can fill maximum of 6 electrons. Again look at this, what I am saying, in each p subshell, okay, in each p subshell, sorry, in each S subshell we can fill 2 electrons. Okay, in each p subshell we can fill 6 electrons. Okay, in each D subshell we can fill 10 electrons maximum. Okay, like that F subshell if you take 14 electrons maximum. These numbers you need to remember. So S subshell maximum how many electrons? It can accommodate 2. P subshell 6, D subshell 10, F subshell 14. Okay, right. Now look at this. We have P subshell now. See, S subshell is over, maximum 2 over. Next one is P subshell. How many we can fill maximum? 6. How many we are remaining with? 4 over fifth one. So here it will be. Next, carbon atomic number is 6. So we have 6 electrons. So where do you fill this? So 1s2, 2s2, 2p. See 4 electrons over out of 6. So remaining 2 you can fill here. Okay. The next, nitrogen atomic number 7. So now tell me, 7 electrons are there. So 1s2, 2s2, 2p. See 4 over out of 7. So remaining 3 you can fill here. Okay. Next, nitrogen, oxygen 8. So same 8 electrons now. So 1s2, 2s2, 2p4. Okay, like that you can make filling of electrons in p orbital up to it becomes a 6 number. Okay, so next, oxygen, fluorine, neon. Okay, this is 9, this is 10. So tell me here for both cases it's 9 electron, here it is 10 electron, right? Yeah. So it is 1s2, 2s2, 2p. See 4 over out of 5. So remaining 5 electrons out of 9, remaining 5 electrons you can fill here. So 10 means 1s2, 2s2, 2p. See 4 over out of 10, remaining 6 will be 10 minus 4 is 6, remaining 6 is filled here. Okay, like this. It is over up to here. Yeah. The next one here, 11th element is sodium. So sodium atomic number is 11. So 11 electrons are there. So up to 10 electrons if we have, we can fill it like this. Okay, now it is easy. So 11th electron now, so up to 10 electrons means we can fill like this, like a neon element configuration only. So neon 10 over now. So the remaining electron, the next extra electron, where it goes? See, because why we are doing like this? See in K subshell, how many electrons we can fill maximum? First shell 2, second shell 8. So 2 plus 8, 10. So 10 over. So sodium is atomic number 11 now. So that 11th electron should go to the third orbit. So here third shell it comes. Okay, in third shell we have n equals to 3 means what are the L values possible? 0, 1, 2. So L value possible 0 means first you take this as s orbital. Which s orbital? 3s orbital. Okay, so that 11th electron now it becomes 3s1. Okay, if 12th electron also is there means it becomes 3s2. If 13th electron is there means it goes to this 3p1. Like that p orbital can accommodate how many electrons? Next 6 electrons it can accommodate. Okay, right. Now it is easy to write the electronic configuration. Just listen here. Sodium is over, up to here it is over now. Next 3s1. So 10 plus 1, 11 over. Next sodium, magnesium. So tell me, magnesium 12 electrons. How can you write this? 3s2. Okay. Next aluminium, 13 electrons are there. 3s2, 3p1. Okay. Next silicon, 14 electrons are there. Same neon, up to here same electronic configuration. If I write neon means that is like this inside. Okay, 10 over. Next 3s2. Out of 14, 10 electrons are over now. So 4 more are there. I can fill 2 here and remaining 2 in the p orbital. Okay, next silicon. Next phosphorus, 15. What you can write? 15 electrons means neon 10 over 3s2, 12 over 3p3, 15 over. That's it. Next phosphorus. Next sulfur, 16. So what you can write? First neon, so 10 over after that 3s2 12 over 3p4 all 16 over. Okay, next here sulfur, chlorine 17. So how can you write this chlorine? Chlorine, so it becomes how much? 17 electron, neon 10 over. Okay, the next 3s2 3p5. Okay, the next chlorine, argon. Argon means it is 18 na? So 18 electron. So clearly you can observe here, after neon 10 we are filling these orbitals also, 3s2 3p6. So all electrons are over. So whenever you have 18 electrons in the given element, you can directly represent it as argon. Okay, now if I write 19th element is potassium. Okay, so potassium, how can you write this 19 electrons? Simply you can represent like this. See, up to here argon over now. So argon means you can write argon 18. So the next electron, see 3s is over. After that, instead of writing 3d, we need to go for 4s. Okay, why 4s? When we are writing this n and l values, so n value is 3 you are saying. So for d, see, if l equals to 0, that is s. L equals to 1 means you are saying it as p. L equals to 2 means this is a subshell number, na? 2 means it is d. L equals to 3 means you are saying it as f. Okay, so now take 3 plus d, d means how much? 2. So this is 5 number. Whereas if I write 4s only, 4 plus s means 0. So it is 4 only. So which is smaller, n plus l value? This is smaller na, this is smaller na. That's why you need fill the electrons in the lower energy, lower numbers first, lower n plus l value first, then fill electron in the higher energy levels. Okay, so always electron should be filled in the lower energy, the next higher energy. So that's why we are filling in 4s instead of 3d. Okay, the next 18 electron over out of 19th, the 19th electron is at here, 4s1. Okay, next after potassium we have 20th element, calcium. Okay, so 20 electrons are there. So you can simply write argon 20, next 4s2. Okay, next after this let us fill up to 30 elements. Okay, after this 21st element is a scandium. Okay, first knowing up to 20 is important now. Okay, next 21st element, this is scandium. So I hope you know that periodic table how it will be. Left side S block elements are having metals, P block elements are non-metals, in between we have D block transition metals. So here we are discussing about now transition metals, that is D block 3D series elements. Okay, right. So now sir, how can I identify an element belongs to S block or P block or D block in the periodic table? See, the last electron of calcium, where it is entering, the last electron is going into s orbital now. So you can say it as an S block element. And for potassium also, last electron is entering into the S block element, S block on, like S orbital only now. So you can say these two elements are belongs to S block. Whereas if you observe these elements from here to here, from aluminium to argon, all those elements, last electron is entering into the p orbital. See, if you observe p subshells right now, so it means all these are which group elements? P block, which block elements? P block elements. Okay, P block elements. And if you observe which group particularly, which group element they are, see, if you observe how many valency, like last higher energy level, how many electrons are there? So higher energy means what? See, if this is a nucleus, these are the paths, circular paths I am writing. Okay, this is n equals to 1 lower energy level, n equals to 2 little higher energy or more higher energy. Like that, if you go on away from the nucleus, energy increases. So more away from the nucleus, more is the energy for that. So which is higher energy for these elements now? So here 3 is higher energy now if I write. So 3s 3p are highest energy level. So we can call them as valency electrons. How many valency electrons for aluminium we have? 3 valency electrons. So now what do we know? What we can do with that valency electrons? Yeah. So during a chemical reaction, only these valency electrons will take part in the reactions. These inner electrons, they won't participate. Only ఈ లాస్ట్ ఎనర్జీ లెవెల్లో ఏ ఎలక్ట్రాన్స్ అయితే ఉన్నాయో ఆ ఎలక్ట్రాన్స్ మాత్రమే కెమికల్ రియాక్షన్స్లో పార్టిసిపేట్ చేస్తాయి. అందుకోసమే వెన్ అల్యూమినియం ఈస్ డూయింగ్ సమ్ కెమికల్ రియాక్షన్స్ ఇట్ విల్ డైరెక్ట్లీ కన్వర్ట్స్ ఇంటూ Al+3 ఫామ్. అల్యూమినియం ఎలా మారుతుందమ్మా Al+3 లాగా మారుతుంది. సో వై? బికాస్ ఇట్ హ్యాస్ 3 valency electrons. By losing these 3 valency electrons it get a noble gas configuration of neon, right now. So that's why it loses these 3 electrons. So sir, what happens by gaining noble gas means noble gas configurations are highly stable. So in chemistry everything happens in complete periodic table you are seeing now. So they all of them do chemical reactions to become stable something like the nearest noble gas configuration. See, for aluminium what is the nearest noble gas? We have neon. Okay, like that aluminium, silicon, phosphorus, all these elements. Like for chlorine what is the nearest noble gas we have? See, for chlorine nearest noble gas is argon. So it has a 5. By gaining one more electron it becomes like a noble gas like argon. So that's why it will try to that's why chlorine try to gain one electron, whereas sodium, aluminium, magnesium they try to lose the electrons and becomes their nearest noble gases. Okay, everything in the chemistry happens to gain stabilities. Okay, right. Okay, so now up to here it is clear now, right? So now what is the valency electrons of silicon? What is the valency of silicon they will ask. You see how many valence electrons are there here? 2 plus 2. So 4 valence electrons, so its valence electrons are 4. For phosphorus how many are there? 5. Okay, for sulfur how many are there? 6. Okay, like this you can count. Okay, now let us discuss about electronic configuration from scandium. So scandium atomic number is 21. We have 21 electrons. Okay, where do we fill these 21? First 18 electrons in the argon. Okay, 18 electrons in the argon. Then next out of 21 18 is over. Then next 4 is 2. So 20 electrons are over. 21st electrons goes to the d orbital, 3d1 orbital, 3d1 electronic configuration. Now again I am writing this more clearly, you just follow me. These 21 electrons are there now. First you fill in the first 1s1, like 1s orbital. So 1s2, next 2s2, next 2p2, 2p6 because maximum we can fill 6 electrons in the p orbital. Okay, then next 3s2, next 3p6. How many electrons are over up to here? You just count 2, 4, 10. Over 10, 12, 18. So instead of writing this much big numbers this many times, you can simply represent it as a argon. 18 electrons, so that is indicated by argon. After 18 we have 4s, 2, 3d, 10, okay, 3d, 1. Okay, this is the electronic configuration of scandium. Okay, now sir, how many valence electrons are there? You just count here. How many are there? 1 plus 2. So these are the 3 electrons or valency for this scandium. Okay, right. Next one here, after scandium we have scandium, titanium. Okay, so titanium 22 right now. So 22, I will tell you some tricks also to write the electronic configuration, no worries. So 22 means argon first, argon 18 over now. After 18 argon, then what are the 2 orbitals we have? One is 4s, 3d. Okay, now what you need to do is out of 22, 18 over now, remaining 4 are there now. So 2 here and 2 here. So 22, 2, 2, 22, 2, 2. Like that you can remember. See 21, 2, 1, 21, 2, 1. Again 21, 2, 1. See 2, 1. Like that you can understand. Okay. Next scandium, titanium, vanadium. That is 23. So tell me, how can I fill these 23 electrons? Argon 18 over. After 18, 4s, 3d. So 23 now. So 23 means 2, 3. That's it. So 2, 3. That's it. Okay. Argon over. This is over. Vanadium. Chromium. So chromium is 24. So what you will do is write argon 18 first. 4s, 3d. Okay. Now we will fill this in the chromium later. Just write it like that. You just keep it in a box. We will discuss about this. Okay, it's chromium. Next, who is the 25th element? Manganese, 25th. So what you can do is 25, argon 18. So 25 now 25. So 4s2 3d 5. Okay, next iron, ferrous 26. So what I told you, just make it like 4s 3d. So 26 now 2 6. So 2 6. Okay, next cobalt 27. Four s 3d. 27 now 2 7. So 2 7, that's it. Next cobalt, nickel, copper, zinc 28, 29, 30. So 28 now, so 4s2 3d 8. Okay, copper again put it in a box. I will discuss about these two things. 4s2, okay, 3d. Okay, I will tell you about this. You just keep it like this, 4s 3d. Next, what about zinc? So 30 now. So 30 means 4s 3d. Okay, 30. So here 2, here 10. Like this you need to fill. 30 means. Okay. Now if you observe the trend, it is something like D1, D2, D3. So what you can expect here for chromium? You may expect it something like 2 here, 4 here. So 3D4 it becomes. But remember, when it comes to D subshell, so D subshell is like this. In D subshell there are 5 d orbitals. In D subshell how many d orbitals? See, I told you something like this. Shells are indicated with symbol N. Okay, in these shells we have subshells. Subshells are indicated with symbol L. Subshell are indicated with symbol L. In each subshell there will be something called orbitals. What they have? Orbitals. Sir, how many orbitals are present in a shell means, in a subshell means, you can take it like this. In a subshell, number of orbitals. Number of orbitals. Number of orbitals is equals to 2L plus 1. Okay, it means here I am saying S subshell. In S subshell how many orbitals are there, sir? So for S subshell what is the L value I told you? 0 no? So 0 plus 1. So it will be having only one orbital. In number of orbitals in S subshell will be 1 orbital. In each orbital, what I am saying, that each orbital should be indicated something like a box like this. In each orbital maximum you can fill 2 electrons. How many electrons we can fill? 2 electrons, like opposite directions like this. Okay, right. So when it comes to now here we are discussing about d orbitals now, d subshells and d orbitals. So now in d subshells, in a d subshell you tell me now how many orbitals are there in d subshell. In d subshell how many orbitals are there? So for d subshell what is the L value we have? L value will be 2. Okay, so 2L plus 1 is the formula to find number of orbitals. So 2 to the 4 plus 1. 5 d orbitals are there. How many d orbitals are there? 5 d orbitals are there. So that's why I have represented them with 5 boxes here. So each box represents 1 d orbital. Okay, so like that, how many electrons here I am writing for chromium? 1, 2, 3, 4. Okay, so 4 if I write, if I give one more electron also into this d orbital, then all d orbitals are half filled, like half of them are get filled. So that's why what I am writing here is, writing this as 4s1, so 3d5. So remember this, put a star mark. Okay, then the electronic configuration becomes like this. See, for all elements what I told you the simple trick, if it is 21, 3d1, 4s2, 22, 3d2, 4s2. Okay, like that I told you. When it comes to 24, don't say it as 4s2, 3d4. Okay, make it 4s1, 3d5, just for becoming half filled electronic configuration. Half filled electronic configuration. Okay, you can write in that way. Right. So in the same way we have here. So 5 boxes means Each box contains 2 electrons. Each orbital contains maximum 2. So 2, 2, 2 like that. Maximum electrons we can fill it as 10 electrons, right? So half filled means 5 electrons, full filled means 10 electrons in the d orbitals. See here for copper you can write it as normally 3d9, 3d9, 4s2 we can write. But if I shift one electron from s to p, what happens? What happens again here also? It becomes like 4s1 3d10. So 4s1 3d10 is more stable electronic configuration now, because all d orbitals are getting filled. So that's why electronic configuration of copper also changes as 4s1 3d10. Okay, like this you can remember. Now what are the two orbitals with abnormal electronic configuration? The first series are 3d series, that is chromium 24 atomic number and copper 29 atomic number. So these are the elements to be remembered with exceptional electronic configuration from 3d series. Okay, right. So is this clear whatever we discussed till now? Now let us make some questions on this. Firstly, let me ask you some random elements in their electronic configuration. Write the electronic configuration of phosphorus, nitrogen and phosphorus. So how can you write this? Nitrogen, what is the atomic number we have? 7, right? Next, for this phosphorus it is 15. Okay, then write. So 1s2, 2s2, 2p3. Okay, for phosphorus also 1s2, 2s2, 2p6. So 10 electrons over, it is 15. Next 3s2, 3p3. So 15 out of 15, 10 here, 2 here, 12 over 3 here. But if you observe, this is 3s2 3p3, this is 2s2 2p3, here 3s2 3p3. So it means in the periodic table, if you take a particular group of elements, what is that particular group of elements means? Like what are the carbon family elements we have? Carbon, silicon, germanium, tin, lead, like that. If you take, all these elements have similar electronic configuration. It means same number of valence electrons. When it comes to nitrogen family, nitrogen, phosphorus, arsenic, antimony, bismuth, if you take all these elements, you are going to see something like this: 2s2 2p3, 3s2 3p3, 4s2 4p3, 5s2 5p3. This is the trend you are going to see. Now what I can write for all these 15th group elements, the general electronic configuration as ns2 np3. What I can write? ns2 np3, because everything is remaining same, but just these n values are getting changed. Here it is 2, here it is 3, the next bottom element, this is become 4, this is become 5s2 5p3, 6s2 6p3, like that you can write. Similarly, if you know the electronic configuration of carbon, you can write for the remaining elements of that group also. Now what is the electronic configuration we have? This is 1s2, 2s2, 2p2. So what is the valence shells we have here? 2s2 2p2 now. Then for silicon also it becomes, write the first here noble gas here, what is that? Neon, because 14 now, so 10th nearest noble gas is 10. Then next 3s2 3p2. For this one you can write it as argon, okay, 18. So 4s2 3d10, 4s2 4p2. Like this if you observe, 3s2 2s2 2p2, 3s2 3p2, 4s2 4p2. So you take any group element, they have almost a similar electronic configuration as like the first element, just change them this number. So what is the general electronic configuration for carbon family? ns2 np2. Okay, similarly for halogens, what you can say? For halogens, even if you know for fluorine, you can write the remaining elements also. For halogen, what is this? Like atomic number 9 now, so 1s2, 2s2, 2p5 you are writing, so 9 electrons are over. So what is the highest energy level? That is 2s to 2p5. So fluorine, chlorine, bromine, iodine, you take any elements, they have general electronic configuration, valency as like this, ns2 np5. Okay, like this you can write it for any element. Okay, so once again, first understand first 20 elements, the next 3D series, first 3D series elements done. Mostly whatever the electronic configuration or related questions comes, that can be sorted out. Okay, now you know, even you are a chemistry student or any other science background student, whether physics or math, bio student also, these electronic configurations are important, because anyways you are having at least some kind of link with the chemistry part in your bio part or in any physics syllabus. So there also you need to use this electronic configuration sometimes. Okay, so it is very important to learn. So try to go with this electronic configuration, try to practice them once again, and if you have any confusion, please let me know in the comment box. Okay, right. So in the next class, again I will be linking some topics from here, electronic configurations, finding their oxidation states, and also related to the mole concept. All these things we are going to discuss in the upcoming sessions. You just stay connected with us, and as I mentioned, go with this electronic configuration once again. Thanks for watching. Stay connected.